So thank you very much. Maybe I use this microphone here. And it's great to have these views on how to deal with spent fuel and have different options and scenarios for the future. And now we also want to have more licensing of new nuclear power plants. And we will have the honor to have David Howell here, President of America's Operating Plant Services of Westinghouse. And we will hear especially about licensing new nuclear power plants in different regulatory regimes, because that's one of the areas where we need to be more efficient, because if we're going to have nuclear plants all over the world, in new countries, we also have to have efficiency in how to get the licensing through. And please join me in welcoming David Howell.
Well, thanks to the screen, they've reminded you 5 times that I'm what stands between you and lunch. So we'll try to make this as quick and efficient as possible. Thank you, Agneta, for inviting me here to talk about licensing today. Unlike Patricia, I will not ask you to speak in Portuguese, so I would probably rather speak in the nuclear English that she referred to. So we'll try to do that. One thing about licensing I think that is very important to understand. If you're going to have a nuclear program that has public trust that we heard about earlier from Camille, you have to have a strong nuclear regulator that is efficient and is building confidence in the ability to both construct and operate a nuclear plant. Okay, I thought this would work if I pointed back there, but apparently it isn't. So if you can move to the next slide, please. So this comes really in a couple of different ways related to the techniques and methods of regulation. One being a very prescriptive type regulation, and the other being more of a non-prescriptive or performance-based regulator. And you can see on the screen a couple of examples of what I would call, and I'll go into some more detail of the differences. But clearly the United States Regulatory Commission, the CNNC from China, and Indian Atomic Energy Regulator are very prescriptive type regulators. Some performance-oriented based regulators would be the ONR in the UK and the Canadian Nuclear Safety Commission. Next slide, please. So what is the, if we can move to the next slide, what is the difference and what is it that differentiates these two type of regulators and their approaches? Prescriptive is really a type of regulator that gives a very specific list of detailed requirements that you have to meet when you're going through a licensing process. It's a minimum set, but it's also a very defined set of requirements. It's less flexible. However, it typically results in a legally binding type of document that when you are done, you know you are done. On the other hand, a performance-based regulator is a little bit more flexible. They lay out principles on the type of things that have to be achieved in the license, and they allow the reactor designer and the constructor a little bit of flexibility on how to meet those. However, there is some degree of uncertainty when the regulation is done and the opportunity for some challenges down the road. So both getting an outcome, but two different approaches on how that outcome is achieved. Go to the next slide, please. In the United States, I want to walk through a little bit on the 10 CFR 52 process, because this is, as I said before, very prescriptive, but it's a little bit unique in the industry. It was called back in the 1990s, when we actually came up with it in the United States, the one-step license process. It's quite simply putting together two things into that one step. First would be a design certification, that very prescriptive, detailed definition, almost a checklist of what it takes to meet the expectations of the regulator. In the case of the 81000, which I'll talk about in a minute, that was a very rigorous review of the designs that went into that plant, especially on a first-of-a-kind passive safety plant. That was coupled with the early site permitting process, where the candidate utilities would map out the location for the nuclear plant and all of the seismic constraints and all of the various cooling abilities for a heat sink and the various landscape type issues were addressed and put into that early site permitting process. As you can see the asterisks, both of those were open to public comment early in the licensing process and often in the licensing process, such that the actual early site permit and the design certification were challenged up front, and those technical challenges were met and basically approved by the regulator as we went through the process to give what is called a combined operation and combined construction and operation license, or a COL, that one-step process that we talked about before. Once that is granted, you are basically licensed to operate a plant. And there are some positives and negatives to that, which I'll go through, but that is the license that you have both to construct and operate the plant when that is achieved. So the construction can proceed. The only other time where there's any public interface or comment is really as you go through the inspections of that design, which is what the ITAC inspection program is meant to do. And those comments aren't really in regard to, well, we think the design should be different. It's really more in how have you met the design? Have you met the intent of the design? Detailed inspections, in particular on safety systems, INC, welding parameters, rebar, you name it. There's thousands of inspection points in the design, in the construction process, and hold points in the construction process under the 10 CFR 52 process. Each one of them having to prove that you truly built the plant the way you designed the plant. And I will tell you, that's a challenge sometimes. Because if you can just imagine some of the issues we had at Vogel, where rebar, center-to-center spacing, was specified within a 1/16 of an inch in the design document. Well, has anybody laid rebar here for anything? That's pretty tough to get a 1/16 of an inch. And we ended up having to do a license amendment request to actually give a little bit more latitude in that spacing because it was a licensed operating plant under the one-step process. A little different than just doing a design change like you would normally do in a construction process. Similar things happen in the ways of software reviews and some of the challenges we had there. But in the end, once the ITAAC, once the inspections are done and have proven that you have met the design intent of the plant, you are licensed to go forth, load fuel, and commence operations under that one-step licensing process. Once again, some very positive features of that, where you limit the public comment to the design phase, but also you really are held very closely accountable to actually building what you've designed. Next slide, please. From the standpoint of licensing a single plant across multiple regulatory regimes, I think it's an interesting example of how we went through this with the AP1000. As you know, it has been certified with the US NRC. It was actually certified twice, kind of. The first certification in 2006 was for the AP600 design, and then when it was upgraded to 1000, it was recertified in 2016 through that one-step process that I just walked through. That actually helped us from the standpoint of getting it licensed with the China NNSA. From the standpoint, even though it wasn't a one-step process, many of the features and many of the aspects of that design certification were valuable in getting the PSAR review construction permits in China, as well, especially since it was done in 2006 and we were in the middle of recertifying it for an AP1000 up through that into 2011. And then the fuel load permit in the Chinese regulation protocol, once you have the plant done and constructed and ready to load fuel, you have one more permit that has to be achieved before you can go ahead and load fuel and operate the plant. Once again, informed by some of the things that were going on in the one-step process from the NRC, but also, and you'll see this in a minute, re-informing the NRC, because as you know, through the history of those two projects, the Chinese actually caught up and surpassed the American program, and we were learning lessons in the other direction going forward on that licensing process. With the ONR in the United Kingdom, we were able to achieve general design assessment acceptance criteria in 2017. Now, as you recall, I mentioned them as an example of a less prescriptive but more performance-based regulatory regime. One of the challenges we had there, we had the certification for the AP1000 from the NRC, but they had a little broader principle on what was designed for the diverse actuation system in the INC safety system. And really, it was more difficult for us to actually prove to them that our scheme of individual diversity of INC systems was acceptable because of that fact that it was not a prescriptive regulatory system. And it was kind of bring me a rock, if you will. I don't know how that translates here in Brazil, but it was basically bring me a solution. Well, I don't like that solution so well. Why don't you bring me another solution that meets my need? Well, I'm not quite happy with that solution. Give me a third solution that meets that need. So you got into a little bit of an iterative process on how to actually achieve that principle that they laid out in the less prescriptive type of licensing. Once again, we achieved it, but it was a little bit more difficult to get there. In Canada, we haven't quite built a plant there yet, so it's a little less down the road, but we did finally get a document basically that says there's no barriers to go ahead and license that plant. But once again, less prescriptive. Now basically say, hey, we don't have any barriers. Come back when you're ready to go ahead and build a plant, and we'll go through another process. So I think it's important to see you can have one design that gets treated differently in various different countries' regulatory regimes. It's important for us to have a good handle on that as we go forward. Next slide, please. So one of the things that we think is very important is to try to get some alignment between the regulatory bodies across the world. If we're going to truly grow nuclear generation the way we all have talked about today and truly inspired to do, it's going to take some sharing of that and some balancing of those type of programs. We firmly support the MDEP, which is the Nuclear Energy Agency's multi-design evaluation criteria, which really attempts to try to have some standardization of regulations across the globe. As we do WNA's cooperation on Cordell, we think that's a very good approach to try to drive standardization and licensing. One of the things that I think we learned from, as I said before, in our building four plants actually in two different places between the United States and China, is you inform each other as you go down the path, and regulation can evolve with that for the next units. For example, in China, we were doing a lot of testing, first-of-a-kind testing on the safety system that is basically the identical safety system to what we're building in the United States at Vogtle. We were able to take first-of-a-kind testing on the first plants in China and take some of the results from that and use that to reduce the number of tests in Vogtle on the INC system. And I think that was very helpful to us from a perspective of moving that ball forward, cutting the cost, giving more certainty of the actual result at the end from the standpoint of the regulator. Next slide, please. So a little bit of an update on the AP1000s. As you know, in Vogtle in the United States, we're continuing construction there as we speak. And we're very proud of the fact that construction since 2017 has really picked up its pace and met virtually every milestone that they've had in the last 2 years. And in particular, one that was very significant just 2 weeks ago was when they set the top of the containment vessel, not the reactor vessel, but the containment vessel on the reactor building itself, which is a really, really significant milestone, because that basically means all of the important equipment that you need to operate the plant are inside by that time. So the next steps of that process is basically going through the final INC testing, some of the late, welding and installation of components, small scale components inside the containment. And they will move down the path fairly quickly toward cold hydro testing, hot functional testing, and then eventually fuel load and startup of the plant. Still on schedule for, I think, in the 2021 timeframe for Unit 3. Next slide, please. And in China, we're very pleased to say that really all four plants, the two at Sanmen and the two at Haiyang, have achieved commercial operation through basically early 2019, started in 2018. with the last one getting commercial operation in January. This has been a very great partnership with our Chinese customer here, and really showing how you can take a first of a kind, passive Generation 3 Plus, the only one of its kind, from fuel load to commercial operation in very quick time, 3.5 to 4 months, with virtually 0 trips using the most advanced INC, digital INC systems in the world. We're quite proud of that and congratulate the Chinese utilities for their ability to do that, with the testing team from Westinghouse supporting that. I think that this kind of demonstrates how you can take a design through 2 regulatory regimes and get it to operation quickly by learning lessons from each other and by moving forward from the standpoint of how you standardize regulatory practices across the globe. Thank you very much. We're going to be in a couple of minutes back for work.